Okay, so this is a quick walkthrough through the Microdesktop EOMA68 housing, which you can see here, that is actual size. Whilst this one is the prototype, you can see that I got the VGA connector the wrong way around, and we've taken Ethernet off a thing that's now been replaced with a pair of single stack USB connectors. Now, this I can't believe this. Embarrassingly, I got these the wrong way round, so it was 4-3-2-1 rather than 1-2-3-4. So I previously routed the things all the way around that way rather than routing them there. This way, at least they're nice and even length on there, which is fantastic. So these links are exactly the same because it's symmetrical there. That curve equals that length plus that length equals that length plus that length equals that, and then it splits out again there. So, and it's the same thing with that one. So as far as differential pairs are concerned, they're absolutely perfect. The vias, I appreciate they're a mess, but there, and all these ones around, basically because this is only a 2-layer board, those vias are there to ensure that there's plenty of ground things and you don't get any EM radiation. Likewise on this one here as well. Now, so you can see the tracks over here for the micro SD, alright, and a set of tracks over to the 20 pin header, which is all of the remaining pins that were spare from the EOMA68 connection, and some other things. So I2C comes out onto this as well, and that's just a button which connects to the pin on EOMA68 which is designated power reset. Now on the EOMA68 that goes directly to the AXP209's button, but afterwards it just generates pure software interrupts. So it's up to you. The XP209 just generates software interrupts, so it's up to you what you do with that pin, with that interrupt signal after thing in software, as to whether you run a shutdown command or do something else. Here's the VGA connector. It's a Richtech RT828. I think I can't exactly remember which one it is, but it's quite a big, beefy 20-watt power chip down here. The 3-volt regulator there, so that's 5 volts. I think that's a 5.5 mil standard jack. This is the power management chip, power management regulator that converts anywhere between 7 and 21 volts into 5. That's just a standard 5 volt to 3.3 regulator, where some of that power is, one of the things is connected to, where is it? It's connected to one of these pins anyway. Now, the main reason why I wanted to show you this is because this is the 2 layers of the things. This is the red conversion. See those red pads? Let me put it on the red layer, so that will be bottom. That's underneath. Okay, you've got 3 buffer chips, one for red, one for green, one for blue. So R, G and B, or whatever it is. So all it does is buffer the signals a bit and provides a stable voltage. And you see these resistors, they're half percent accuracy times 2 times 2 times 2 times 2 times 2 times 2. So it starts out with something like 68 ohms or something, goes up to 500 or something. But basically it's a very crude version of a digital to analog 6-bit converter, which is why you have to have half percent accuracy resistors. If they're below 0.5%, then the last bit ends up going into the error thing. So you have to watch that thing. Now, let me just expand it out a bit. You can see here there are vias all over the place because this is analog thing. So I wanted to make sure that it was definitely a grounded thing, and then the surrounding, that's the track, that's the output, that it joins all of these together, and you can see I've got vias surrounding all the way around here, and then the other one the other ones as well. So this one here, that one track is the one that goes on those, and likewise for the other one above. But basically, these three chips are on the bottom. They're just 7.4 buffer chips. And flip it back to the top layer. Yeah, wrong one. Top. These are the pins where the RGB TTL comes out from the EOMA68 connector, and you can see it. All it does is every single one of them drops down through the layer, goes things. So this one drops down and goes to there. That one drops down and goes directly. Where is it? It's probably not one of the pins that's used. That's one of the SPI signals, I think. That one drops down there and goes to that one. Yes. So, but yeah. So it's basically going. Every single one of them goes through the board, which is why it's so important to have all those ground wires, which I just added today. So that's So that's basically it. It's not a lot, technically speaking.